So hello guys, welcome back to my channel Coach Shiba, where I'll be posting DSS solutions each and every day, and today is day 12th of doing so. The problem that we will be looking forward to is remove duplicates from sorted array, which is lead code problem number 26. So let's directly jump down into the problem and see what it really is. So the problem states that will be provided with an array where every element will have a duplicate, and no, it's not necessarily that it will have a duplicate, but there will be some numbers who will be having their duplicates, and we need to remove them in such a way that the first will be creating a vector in which we need to, or we might be manipulating this array itself, in which we will have to remove all the elements, and the first k elements, the first like n unique numbers within the array will be placed at the first n indexes, and after that it doesn't really matter what elements we leave beyond the returned value k. So this function will expect a vector and a value k, and it will iterate through the vector till k as it is shown within this. Okay, so remove the duplicates in place so that unique elements appear only once. Okay, so relative order of these elements should also be the same. What the So the thing is that the array is already sorted, and since we are returning something out of it, this result should also be in a sorted manner. Okay, so let's take a few examples and let's understand, like let's dive deep into this problem. Yeah, so let me take this example 00111122. Okay, so we need to create, so the answer that will come out of it will definitely be 0 1 2 3 4, and since size of this array is like 3 6 9 10, so size is 10. So uh, from, like, after these all unique numbers, it doesn't really matter how many numbers till like the end of this array exist, how many different numbers exist here. So the function will check till this point, this is the limit point. Okay, so that's fine. Now, to solve this problem, the first approach that comes into our mind, since so what we are going to do in this problem is that we will, the very first approach of this problem is really the simplest. We will be using set data structure. Set data structure. So for that I need to explain like what set data structure really is. So set data structure is a kind of a container element within C++ STL, in which what happens is that whenever we enter anything into the set data structure, it has few properties. One of them being it will always input, or it will always store elements in a sorted manner, and the second thing is that it will only store elements once. So these are two properties within set data structure. So what will happen is that when we will iterate through this array and we will insert everything into the set data structure, it will automatically sort the array after every iteration, and the second thing which happens is that it will remove duplicates. So we will finally have 0 1 2 3 4 within the set data structure, and then we can again convert this data structure into a particular vector, uh, through which we can just like return the size of this vector, and this vector will be checked. Since yes, I do really believe that since the problem states that the everything should be in place, so we'll be reinserting elements into nums array. Yes, so we don't really require to make a new array to return anything like that. So this is the very first approach to this problem. Quite easy if you understand how to implement such data structure. Okay, so the second approach to this problem, the second approach relies on pointers. We'll be using two pointers here. The first one, we'll be using two pointers here, and let's discuss how we're gonna solve this problem using two pointers. So the first thing that we're gonna do is we will compare all the elements. We will take two pointers, such as we can take j here and we can initially take I here. The work of this ith pointer is to check elements which are previous to it, if they are equal to this element or not. So we can have this pointer as a check pointer, which will check if arr of I is not equal to arr of I minus 1. So what are we gonna do is, if we see an element which is not equal to the previous element, then there is something that we're gonna do. Uh, we will take ARR, we will update ARR of J to ARR of I. So how is it working? It's working like, the simplest way to understand how it works is to dry run this solution. So basically, at first, since these two elements are equal, our ith pointer will simply just go ahead. When these two elements are equal, we will go ahead and ith pointer will come here. And now in this situation where the current element and previous element are really different, then we will be updating our element at the jth pointer, and we'll update it to 1. And after that, since after that we will just increase our jth pointer, we'll move over here, and we will definitely increase our ith pointer over here. Now since these two elements are equal, we will just move forward. I will come up here, and again it will happen again. I will just increase, and when I will be at this point, uh, this is the same problem. There are two different elements. Current is not equal to previous element, so we will just be updating ith pointer with jth pointer. So after this, our array will look something like 2 1 1 1. And if you can just observe this, every time we have different elements, we will update, and like j will be at this position now. So j will be 0 1 2. Now j will be here, so j will be updated to 3, and then at last j will be updated to 4. And it doesn't really matter what numbers are beyond this. We'll be taking j, and j will have the count of unique elements. Yeah, we will return j because j will have the count of all the unique elements within the array. Okay, so this solution will have a time complexity of, big of n in the worst case, and it will have a space complexity of constant space complexity, because we're not gonna take any other vector beyond like this scope, like beyond this input. We're not gonna take any other vector. So this is fine. The earlier approach, where I was taking set data structure, had some space complexity of big of n. In let me just write it down. So set data structure approach has a time complexity of, it will have time complexity of big of n, because the first iteration would be there when we are entering elements into the set data structure, and the second iteration will be when we are copying the set data structure into the original nums vector. So like 2 times of big O of n is big O of n, and space complexity of it would also be big O of n because of obviously the set data structure. So definitely this is the most the second approach is the most optimal approach. That's it. Now let us implement whatever we let us implement the logic and see if it works. Okay, so I'll be implementing the optimal solution, or let me say two pointer approach int j. Okay, so we'll start I from 1, we'll go till n, and we will have to check if, yeah, if nums of I is not equal to nums of I minus 1. What are we gonna do then? We will update nums of j with nums of I, and then we will do a j plus plus. After that, if in any condition, we will just be increasing I. In the default condition, we'll just be increasing I. So at this point I can just return j, and I think my solution is done. Let me see if it works. Yeah, it works. Yes, my solution works and it is optimal and everything is fine here.